numbers. That's what this lesson is about. The types of numbers. So by way of review, we have the most basic type of numbers that you learn from a very early age when you want to count something. We call these the counting or the natural numbers. And it starts with 1, 2, 3, 4, and so on. Okay. If we add the number 0, which is an abstract concept, we end up with something called the whole numbers. 0, 1, 2, 3, 4, and so on. If we add the concept of negative numbers, we end up with something called integers. So they start with 0, 1, 2, 3, but also negative 1, negative 2, negative 3. Okay? Integers. But there are actually numbers between all of these. So we start into something called the real numbers. The real numbers are all numbers that you can think of for the most part. There are actually some numbers that aren't real numbers, but that's outside the scope of this class. But there are two types of real numbers. There are rational numbers, and there are irrational numbers. Rational numbers are numbers that can be written as fractions. Let me give you some examples. 1/2, 2/3. They can be expressed as decimals. 0.5, 0.6666 forever. Okay. Note they can be represented as decimals that stop or decimals that repeat forever. Irrational numbers cannot be written as fractions or ratios of whole numbers. Okay? So they cannot be written as fractions. The Greeks actually thought under Pythagoras that these numbers didn't exist. But there are infinite numbers that cannot be expressed as fractions. The most famous is pi. Pi is approximately 3.14159,265,358,9796,2364, ... and so on and so forth. And it goes on forever. So as a decimal, they are decimal values that never end and don't repeat over and over. They cannot be written with a repeat bar. Okay? So another example would be like 0.10, 100, 1000, 1000, 1000001, and so on. Just adding a new 0 that can't be written with a repeat bar, but it's a never-ending decimal. Also irrational are square roots. The square root of 2, which is about 1.414, about 1.414, goes on forever and doesn't repeat. Any square root, unless it's a perfect square, is irrational, square root of 5. The square root of 9 is rational because the square root of 9 is exactly 3. Because 3 times 3 is 9. Right? So by way of review, natural numbers are counting numbers, 1, 2, 3, 4. Whole numbers are counting numbers including the number 0. Integers are whole numbers and negative numbers, negative whole numbers. Real numbers are all those numbers and everything in between. And they include two kinds of numbers: rational numbers, which can be expressed as fractions, which are fractions or decimals that stop or terminate and or repeat forever, and irrational numbers, which cannot be written as fractions. They are decimals that go forever and cannot be written with repeat bars. So let me Venn diagram this here a little bit. Okay, window. Okay, layer editor. There we go. That's what we need. Need a new layer. There we go. Okay, so we have the natural numbers, which include 1, 2, 3, 4, and so on. Here, let's do this. Natural numbers. Then if we add the number 0, we get the whole numbers. Add the number 0, whole numbers. And then if we add the negative whole numbers, like -3, -2, -1, we have the integers. Okay. Integers. And then if we add all the decimal values in between, all the in-between numbers, we end up with something called the real numbers. Okay. Which include two kinds of numbers. This is all the real numbers. Okay, but the real numbers include rational numbers and irrational numbers. Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. Okay. Rational decimals are decimals that stop or repeat forever. Irrational numbers are decimals that go on forever and do not repeat over and over.